Greetings, I'm Lauren McNeely and I'll be explaining number 1 on the homework. So I like this problem because it was a really good reminder of the stuff that we did in the previous courses on how to create vectors and evaluate them. So the question is to find components of the vector RBA along the P and Q axis. So first, you have to find RBA, which is basically saying that's coming from A and it's going to B. So first thing I'm going to do is I'm going to write down the coordinates for that. So the A part is at 1, 2, 1, 2. And then the B component is 5, 1. So in order to find the vector RBA, we're just going to subtract. So it's going to be 4I hat minus J hat feet. And the next thing you want to do is you want to find the unit vector for P, which is going here. So all we know about P is this angle, which is 22.5 degrees. So we can use that to find by just saying that the x component is cosine times the angle I hat plus sine times the angle J hat. This simplifies to 0.92 I hat plus 0.38 J hat. And then the Q vector, what you're going to do is you're going to add 90 over here to get an angle of 112.5 degrees. So this vector, U, the unit vector for Q, is just 90 degrees away from this vector here. So that's all I did. Okay, so then Q would be the same principle. So the x component times the angle that it's at I hat plus sine times the angle J hat. So in order to find the component of this vector AB in respect to these two, we have to do the dot product. So that's what I'm going to do now. So RBA dot UP is going to be multiplying RBA 4 times the component of P, cosine. So 4 times cosine 22.5 degrees. And then you want to multiply the y components together. So you're going to multiply -1 times the y component of P, which is sine 22. And when you're doing this, you want to make sure that you're not mixing up your x and y components when you're solving this. And then this just ends up to be 3.313 feet. And we're going to do the exact same thing for RBA dot UQ. So you're going to multiply the x component of RBA times the x component of UQ. And then the same thing for the y component. And this is going to give you an answer of -2.455 feet. So all this is saying is that this vector right here, the projection to this, to UP, is this amount. And the projection of this vector to this vector is about -2 feet. So that's how you do number 1. Thank you.